Okay, so this unit is all about polygons, and so first off we need to look at these polygons, specifically quadrilaterals and what exactly they are. So if we look at these quadrilaterals, we have to look for all the possible names for these shapes. So obviously these are all going to be quadrilaterals, so we don't need to worry too much there. That's taken for granted. But what else is this? Well, this is also a trapezoid. And it's a trapezoid because we see that we have two sides that are parallel, two sides that are not. That is the basic definition of a trapezoid. Now, if I look at the next question, number 2, I can see that those two non-parallel sides are congruent. That is an isosceles trapezoid. We can also say that it is a regular trapezoid as well. But yeah, definitely an isosceles trapezoid. That's the most specific name for this quadrilateral. It's isosceles because just like an isosceles triangle, these two legs are congruent. All right, here we have opposite sides being parallel. So this is going to be a parallelogram. And that's the basic definition. That's all we can say about that because we don't know anything about the angles there. We just know, or the sides being congruent. We just know that opposite sides are parallel, making this a parallelogram. All right, number 4, we can see that all these sides are congruent, so this is a rhombus. Because it's a rhombus, it's also going to be a parallelogram as well. All rhombi are parallelograms, so that's something to consider as we look at this. Yes. Right. Number 5, we can see that it looks like a rectangle. Opposite sides are congruent, and the corners are 90 degrees. So this is, in fact, a rectangle, which actually also makes it a parallelogram as well, because rectangles must have opposite sides being parallel. And so number 6, we can see that this is a square, and all square are also rectangles, and all rectangles are parallelograms. And because it's also a square, it is also a rhombus as well. So it's a whole bunch. Just understand the main difference between a trapezoid and a parallelogram, and you really can't go wrong with these. But definitely review the definitions and the key characteristics that we examined in class. And of course, we have some applicable properties for these. So here we want to solve for x. Now this is a trapezoid. And so with trapezoids, we want to, actually, we don't know this is a trapezoid. I'm sorry, how silly me. I don't know this is a trapezoid. I was just assuming that because it looks like these two bases are parallel. But I can't make that assumption. However, I know that the sum of these angles is 360 degrees because of the formula n minus 2 times 180. N is the number of sides. There being 4 sides, I get 4 minus 2, which is 2, and then 2 times 180 is 360. So here I have 115 plus 65 plus 22x plus 7 plus 20x plus 5 equals 360 degrees. And so using this equation, I can solve for x. So here I have 22x and 20x, which is going to give me 42x. And then I just have to add 115 plus 65 plus 7 plus 5, all those other like terms, and that's going to give me 192. So 42x is going to equal 360 minus 192, which is going to be 168. And so to get x by itself, I just need to divide by the 42, and that gives me an answer of 4. Nice, right? Number 8 looks like a parallelogram, but again, I actually can't make that assumption, although actually I can here, because with this, I can see that opposite angles are congruent, which means that 77 must equal 16x minus 3. So 16x minus 3 is equal to 77. So we get that 16x is equal to 80. And if we do that 80 divided by 16, we get that x is equal to 5. And by plugging that in, we can see that these two opposite angles are also congruent. Now, if I wanted to, I could add up all these angles and set it equal to 360, just like I did in number 7, and I would still get the same answer. All right, number 9 and 10, we're looking for the measure of one exterior angle. Inside of regular polygons, all of the exterior angles add up to 360 degrees. So if we want to find one, we just have to divide it by how many angles or how many sides there are. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides. So if I do 360 divided by 10, I get 36 degrees for each exterior angle. Likewise, in number 10, it's going to be the same 360 degrees divided by the 8 sides that are here now. And so this 360 divided by 8 is going to give me 45 degrees for each exterior angle. And that's exterior angles. Now the interior angles, remember, is going to have the formula n minus 2 times 180. So if we want to find the measure of 1, we would just need to divide that by how many sides there are. So here we have 1, 2, 3, 4, 5, 6, 7. And there are 7 sides, so that's 7 minus 2 times 180. We're going to divide that by how many sides there are. So this is 7 minus 2, which is 5. And 5 times 180 is 900. Now if we take that 900 and divide by 7, we are not going to get a perfect number, but we can round this off and say this is about 127.57 degrees. Again, the instructions say to round to the nearest tenth. So that's perfect. Number 12, we have another octagon. So we have 8 minus 2 times 180 over 8. The 8 minus 2 is 6, and when we multiply that by 180, we get 1080. And we're going to divide that by 8, and we get that the angles are exactly 135. That looks horrible. 135. Each interior angle is 135 degrees. So n minus 2 times 180 is the sum of the interior angles, and divided by how many angles there are to get how much 1 is. Yep, and so actually here, we just want to find the sum, so that's nice. So this is actually a step easier. This is just n minus 2 times 180. So here we have a 6-sided figure, so it's just going to be 6 minus 2 times 180, and that's going to be 180 times 4, which is going to give me 720 degrees. The hardest part about 14 here is trying to figure out how many sides there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to have 12 minus 2 times 180 degrees. And so this is just 10 times 180. So that's going to be 1800 degrees for the sum there. All right, and then we have some more parallelogram problems. Remember, with parallel lines, consecutive angles are supplementary. So the same is true with these. These are actually consecutive angles. So if I do 124 plus x plus 56 is equal to 180, I can solve for x. So 124 plus 56, if I add those together, I'm actually going to get 180. So when I subtract 180 from both sides, I get that x is equal to 0, and that's fine. Next up, this is a little bit tricky. This is a little bit ambiguous here. But it looks to me like this 10x plus 20 is this angle G. It is tricky to tell here. I will make sure that on your final exam there are no ambiguous questions like this. 10x plus 20 plus 140. Again, that's going to give me 180 degrees. So we get that 10x plus 160 is 180 degrees. So 10x is equal to 20. So x is equal to 2. Simple enough. Parallelograms also have opposite sides being congruent. So here we know that x plus 14 is going to equal 14. So again, we have another problem where x is equal to 0, and that's fine. Number 18, we get 12 is equal to 4x minus 4. So if I add 4 to both sides, I get that 16 is equal to 4x, or x is equal to 4. Trapezoids. Remember, when we have this median or mid-segment of a trapezoid, this is going to be half of the sum of the bases. So that means that 9x plus 3 is equal to 1/2 of the bases, which is 10, plus 14. So 9x plus 3 is equal to 1/2 of 24. 9x plus 3 is equal to 12. So 9x is going to be 12 minus 3, which is 9, or x is equal to 1. Same with number 20 here. I know that 24 is going to be equal to 1/2 of x plus 8 plus 31. So x plus 8 plus 31 are the two bases. So here, 24, oops. I could distribute this 1/2, but also I can multiply both sides by 2. So I'm going to get 48 is equal to x plus 39 once I combine the 8 and 31. And if I subtract 39 from both sides, I'm going to get that x is equal to, that's an ugly x. Let's give that some plastic surgery there. X is equal to 9. Trapezoids. It's tempting to say that these opposite sides are congruent, but unfortunately they're not. So what we can say, though, is if this is 105 degrees, this angle here is going to be 75 degrees. And I know that because if the bases are parallel, these are consecutive angles, and they are supplementary. Yes. And because this is an isosceles trapezoid, that means that the two bases are actually equal, just like an isosceles triangle. So because this isosceles trapezoid, I can set these two base angles to be congruent. And I can say that 75 is equal to 5x plus 25. Subtract 25 from both sides, I get 50 is equal to 5x, or x is equal to 10. Here we go. Again, we have another trapezoid. This 105 is actually in that corner. And because, again, we have these two parallel bases, these angles are going to be supplementary. So we have 105 plus 77x minus 2 is equal to that 180. 105 minus 2 is 103 plus 77x equals 180. And wouldn't you know it, if I subtract 103 from both sides, I get 77x is equal to 77. So x is equal to 1. Now here we have these diagonals. And so if LJ is 24 and MK is 14 plus x, remember these two diagonals are actually congruent inside of this trapezoid. So 24 will equal 14 plus x. So x is just going to equal 10. And I think that's the last page, and it is. So, know your properties of trapezoids and parallelograms and how to apply them so that you can solve algebraic equations. But the key is also to understand the most specific name or how many names apply to a certain quadrilateral and just really understand those properties.